Hello, everyone. My name is Kunal, and I go to Mission San Jose High School, and I'm in ninth grade. So, my project is a solar panel sun tracker, and I would be glad to show you how it works. So, here we go. Um, Let me see if I can get this in frame. Okay. So, as you can see, there's a solar panel, and let's see how it moves when I shine light on the photoresistors. So, if I shine light here, the solar panel goes and tracks the light, and it works as well in the opposite direction. So how my project works is that it uses two photoresistors, which were on either side of the solar panel, to read the amount of light which is directed towards it. Then it moves a servo motor, which moves the solar panel accordingly. A photoresistor is like a sensor which changes its resistance based on the intensity of light that's shining on it. So, for example, a high intensity of light would cause a lower resistance, while a lower intensity of light would cause a higher resistance. So the pins which the photoresistors are connected to can read this, and it can perform different things using that information. So the way that the motor knows which direction to move the solar panel is that it takes all of these data points and it compares it, and it moves the motor fin, which is connected to the end of the motor, in the direction that the photoresistor with the higher light intensity is. So there's also an LCD screen which shows the light intensity of both photoresistors, and this is my modification to the project. So it gets this information from the analog pins which it's connected to into the Arduino. One challenging aspect was definitely building the wooden frame. Cutting the wood was very time consuming and a little bit frustrating at times. However, I persevered and I eventually made the frame. So this was a completely new experience for me because I've always done more software side things like coding, and this was very interesting to be able to work with Arduinos and breadboards, LCDs, photoresistors, and so on. So I was able to also substitute some parts in my design because of the availability of parts that I had to me. For example, I replaced spring steel with a pipe cleaner and a metal rod with a wooden skewer. In the real world, this would also bring down costs. So some experiences that I gained were working with Arduino and learning how to use a breadboard more. And I joined Blue Stamp Engineering because I love to build things which people can actually use. So I was able to apply some of my coding skills because Arduino IDE is a C-based programming language, and I have some experience with C++, but I definitely learned a lot of new things, such as the motor library and the LCD libraries. For example, instead of the regular LCD screen, which has a 6-pin input and output, I instead used an I2C connection. So the reason I picked this project is because people who do not always have access to power, such as my grandparents, should still have a way to gain access to power. So I hope this project can help them. Lastly, I would like to thank my peers and instructors for helping me along the way. Thank you. Are there any questions?
Sure. So I'll start off, Kunal. You did a lot of research in the servo library, I believe. Can you explain kind of like how the servo determines what angle to write to it based on what the input of the Arduino is?
So there is a power width modulation which is connected to it, and that gives off a different length of signals. You can think of it in a way, and using that, it can determine how much to turn.
Perfect. Anybody else?
No, I like that you did a little modification. Can you do anything else? Do you have any other plans for any other further modifications?
Um, not really at the moment. Um, one thing that I could definitely add is that instead of just making it like a normal USB port as an output for the solar panel, there could be other different kinds of outputs. And also I can make the circuit almost self-sustaining if I add more solar panels.
Thank you.
I also have a question around that line. So in your presentation, you mentioned that light intensity helps you to change the angle, direction, right?
Yeah, yes.
Is it only the parameter light is the only thing, or can it be other parameters? Any climate related, any like a temperature or maybe pressure or wind or any other thing that can be sensed and can influence the move?
Yeah, that could definitely work, but the reason that we use photoresistors is because the solar panel gets energy from light. So if we if we know where the most light is, we would be able to get the most energy. But if we use different sensors, then we could definitely take in different data points and use them accordingly.
I have a quick question. So what made you think of the modification or to even try to modify it?
So I would like to be able to display what it is, and also this helped a lot with the debugging process because it was a little bit difficult along the way to make the motor turn and gain the data from the photoresistors. And also it can allow you to see which direction there's more light, and it can help you when you're placing the circuit, like where to place it best.
That's good. No, I was impressed by the modification, so I wanted to know. Thanks.
Thank you.